Okay, we are on the word problems review. I am going to jump through a couple of these. Um, I'm going to start with the first one. Let's just get started because it's hard. Jacqueline is flying a hydroplane. Okay, that's a plane that lands on water and is descending. So this is Jacqueline. She's flying a plane and she's descending towards a lake at a 13-degree angle. Now, here's what's confusing about this. The angle of 13 degrees assumes if she were to keep going straight, she would be along this line of sight. This is her 13-degree descension. Okay, so that's important. This is 13 degrees right here. She's descending. All right, let's see what else is happening. If she can peek behind her at a 35-degree angle that is 600 yards away from the lake, okay, so she's going towards a lake. Here's our lake right here. She looks behind her at an angle of 35 degrees, okay, so she looks behind her at an angle of 35 degrees. Again, this is the 35-degree angle. She sees something, she peeks behind her, can see a peak behind her. Okay, so it's 600 feet away from the lake. So the peak to the lake is 600 feet apart. Now, what's confusing here is up here with this angle stuff. Again, the angle that she looks at the lake is 13 degrees, so that's 13. The angle that she looks at the peak, okay, so pretend like this is the peak, there's the peak right there, is 35 degrees. Now, we can figure out this angle because we know that 180, because it's a straight line, minus 35 minus 13 is, let's see, 180 minus 35 minus 13 is 132 degrees. So this angle right here is 132 degrees. How much further does she have to fly until she lands? Okay. This is another like kind of geometry thing that you should have learned in geometry, which is like math 1, math 2, math 3. But this angle is 35 degrees and it is congruent to this angle. So that means this is also 35 degrees. Same thing over here. This is 13 degrees. So that means this angle is also 13 degrees. This is called alternate interior angles of parallel lines. Okay, notice that it makes a Z. Let me trace that out again. This Z encapsulates what we call alternate interior angles. Ugh. And so if the top is 35, this is also 35 degrees. Same thing over here. This is like a backward Z. These are alternate interior angles. And so if this is 13, this is also 13. Now, what are we looking for? It says, how much further does she have to fly until she lands? Well, she's going to land on the lake. So we're looking for X, which is right here. We're looking for this side because this is where she's going to land. She's going to land on the water over here. And so let's look at our options. We have an angle, opposite side 60, and we have an angle, opposite side X. So we can use the law of sines because we have, what is this? Angle, side, angle. So what we'll do, we'll say the sine of 35 is to X as the sine of 132 is to 600. All right, we cross multiply. We have X times the sine of 132 equals 600 times the sine of 35. Divide both sides by the sine of 132. Divide by the sine of 132. I should say this entire thing. And X is, let me put it in my calculator, 600 times the sine of 35. And I'm going to press enter. And then I'm going to keep that in my calculator and divide it by the sine of, oh wait, I can't read my own handwriting. Hold on, let me do that again. 600 times the sine of 35, enter, and then divide by that by the sine of 132. and I am getting 463.09. It says round to the nearest tenth, so that'll be 0.1. The answers are at the back of this worksheet, and that is correct. The answer is 463.1 yards. Now that's pretty tough. That picture is difficult. These word problems, half the battle is drawing the picture and getting the picture correct. Let's look at number 2. Chip wants to build a tool shed in the backyard, but is only using the area, now that's an important word, beyond the path through the yard. How large should the shed be? Okay, how large means they're asking for the area. This, number 2, is an area problem. And you're told that you have a triangular shaped bed with sides of 6, 5, and 8. Okay, so if you watched my previous video, you know that we have side, 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 and we're going to use Heron's formula to get the area. Okay, that says Heron's formula. No, it doesn't look like it. First, we have to find S. S is the sum of the sides, 6 plus 5 plus 8, and then that's divided by 2. It is not the average. That is super important. People want to think that this is the average. S is not the average. So 6 plus 5 plus 2, or 8 divided by 2 is 9.5. So S is 9.5. And then what Heron's formula says we do, we take a big old radical, we take S, which is 9.5, and then we do S minus each of the sides. So 9.5 minus 6, 9.5 minus 5, and 9.5 minus 8. And we'll put that in our calculator. I'm not going to take the time to solve that one because the answers are at the back. I want to do a few more and help you get them set up. Let's do number 3. A life preserver is seen floating down a stream. Okay, this is again, the drawing is really tricky here. So let's think about it. We've got a stream and we see a life preserver. I'm going to draw a life preserver. And here's the life preserver. Boom, 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 boom. All right, a life preserver is seen floating down a stream. The life preserver is first spotted at 85 feet away. Okay, so where are the people standing? It's floating down a stream. Maybe they're standing on the bank. Let's give us some grass. So they're standing up here on the bank. And first, they see the life preserver. Whoops. And it is, what is that, 85 feet away. A few moments later, the life preserver is 40 feet away. So then they see it a few moments later, and it's only 40 feet away, making a 6-degree angle between the two sightings. So this is a 60-degree angle between the two sightings. This is sighting number 1. That is sighting number 2. How far did the life preserver travel? So this is what we're looking for right here. We're looking, and my picture's probably not the best, but we're looking for the distance that the life preserver traveled, which is X. Okay. We have, let's see what we have. We have side, angle, side. So for side, angle, side, let's change colors. We have a side, we have an angle, and we have a side. We're going to use the law of cosines. Okay, now notice 60 is opposite X. So if we're looking for side X, we've got to use the law of cosines. We're going to call it X squared. We know that way down here, we're going to have the cosine of the angle that corresponds to X, which is 60. Okay, over here, we take the two sides and square them. So 85 squared plus 40 squared minus 2 times one of those sides, which is 85, and the other side, which is 40. And so we get X squared equals, now somebody the other day, I'm going to try to put this in my calculator and see what happens. 85 squared plus 40 squared, enter. And then I'm going to subtract, and I'm going to put parentheses, 2 times 85 times 40 times the cosine of 60. Close my parentheses and press enter. Okay. We'll have to see if this is correct. I'm getting 5,425. And we want to take the square root of that because we're solving for X. So X equals 73 point, how does it say round? Round to the nearest tenth. So 73.7. 73.7. We're talking about feet here. All right, so there's one example of the law of sines. There's an example of Heron's formula. There's an example of the law of cosines. I want to make you aware, I put my notebook away, but several of these are area problems. Let's skip down and see another area. Okay, this is talking about number 7 is an area problem. It looks like number, what would be the area? Yeah, this is also number 8 is also an area. Now I take that back. This is not an area. What are the respective angles? Okay, so no. This is not an area. Sorry, not an area for number 2. They want to know the angles. So you'll have to use the law of cosines here. It's got 3 sides, so you're going to use the law of cosines to get your angles. Number 9, it looks like snow. I'm trying to find another area. I know there's like 3 or 4 areas. This again is another area. Okay, well, I know there's several area problems. Let's just pick a random one to do. Let's do one more. I've got 4 minutes. Let's do the cat. All right, Paul's cat jumps out of its bed. So boom, here's the cat, and it jumps out of its bed. It ran 18 yards. It turned and then ran 12 yards. And then it turned and it ran to its bed. Now, here's where this gets interesting. Let's talk about these turns. We haven't done one like this. This cat was running in this direction, and then it turned at a, well, it doesn't tell you the angle there, right? Then it was running 12 yards here, and it turned 100 degrees. Now, if it turned 100 degrees here, that's going to, well, this, I should say, this is 100, it turned 100 degrees, and this is a little bit overemphasized. That means this is going to be 80 degrees right here, okay? So we've got side, side, angle. Side, side, angle. We can use the law of sines here, but we have to be very careful. So 80 corresponds with, what do they want to know? How far away is it from the bed? And they want to know this side right here. So I feel like I'm missing something. Oh, 12 corresponds to this angle. So we'll do the sine of 80 corresponds to 18 equal to the sine of x, because we don't know that angle, corresponds to 12. We'll cross multiply here. So 12 times sine of 80 equals 18 sine of x, divide by 18, divide by 18. Now, it's been a while since we've done this. Let me put this in my calculator. 12 times sine of 80, press enter, divide that by 18, press enter, and I'm getting 0.6565 equals the sine of x. Now, to get rid of sine, I have to do inverse sine. So I'm going to do inverse sine on the left, inverse sine on the right, and x is going to be, so let's do inverse sine of 0.6565, and that is 41.03. Okay, I'm not exactly sure where we stopped, but this is, I apologize, this is the angle. Okay, so the angle right here is 41.03. But that's not what we want. We want to know how far the cat is from the bed. So we've got to figure out what this length is right here. So we have to do the law of sines again. My video is about to run out, but I'm going to set it up. So we now know we can do this angle right here. We subtract from 180, and that angle at the top is 58.97. After you subtract everything from 180, you've got this angle minus this angle equals 58.97, and then you have to do the law of sines a second time. So do the law of sines a second time, and the answer is exact. My video is running out. I hope this was helpful.